Yo, what's up? This is your first virtual assignment. Alright, so we're on 4.1, that's it's understanding equivalent equations, but that's page 192. So you guys have done stuff like this before, or it's just a little bit going over it again. You can kind of look over the reviews on pages 192 and 193 if you want to pause the video right now, because you can do that because you guys are at home. Not you. I'm at home. That was the person who's recording it. I'll let you try to figure out who it was. But you can look over 192, 193 to give you an idea. But if you look over on page 194, we're going to give some examples and kind of go through them to review it a little bit. So if we look at A, it says x plus 3 plus 6x equals 13. That's one equation, and there's another equation as well, and they're trying to say, we're trying to figure out, hey, are these equivalent equations or not? So one looks like that, the other one looks like 7x plus 3 equals 13. So there's two different ways to figure out whether or not these are equivalent equations. One, you could say, hey, I'm going to solve both of them. That's the most straightforward way. We already know, hey, we know how to solve it. We need to get what by itself? What do you do to get by itself? The what? Yeah, the variable. So in this case, you'd have to get x, the variable, by itself. And how do you get the variable by itself? You undo what's being done to it in the opposite order. So we could say, hey, well, first of all, we look at this and we say, hey, we're going to combine like terms because everything is adding. When everything is adding, remember the commutative property, as long as everything is adding, any subtracting, we can't do it then. But as long as everything is adding, we can move things around. So we could say, hey, this 6x and that x, that's going to make 7x. 7x will have a 3. 7x plus 3 equals 13. Look, we know both of them are the same. So that's the second way. One is we can solve it all. The second way is making sure that they both look the same. So we know that when we use the commutative property to move them around, this is going to make 7x plus 3 equals 13. This one already looks like that, so we know these two are going to be similar. These two are going to be equivalent equations, which is that's the whole thing that we're looking at. We look at another one later on that page. You see. Actually, let's go to part C, because part B is a pretty similar one. But if you want to pause and look at part B and see how that one's similar, you can do that too. But part C says 2/3 x equals 4 and x equals x. So on this one, you have to solve it one way or another, because this one is already solved, x equals 6, and this one is not. So you have to ask yourself the question, hey, how do I get 2/3 off of this side? Well, you got to remember, to get a variable by itself, you have to undo what's being done to it. So what's being done to x is being multiplied by, right here, this is 2/3 x. This x is being multiplied by what? This right here, this is 2/3 x. That's the same thing as 2/3 times x. So x is being multiplied by, it's being multiplied by the fraction 2/3, because you can multiply something times fractions. If I said, hey, here's 3 whole pizzas, and I said multiply them by half, then you would multiply all of them in half. So here, you have 2/3 is being multiplied by x. You say, how do I undo it? How do you undo multiplication? You what? Divide. So then I would say, hey, I have to divide by 2/3. But you can't divide by fractions. So instead of dividing by fractions, you multiply by the reciprocal. The reciprocal is if you flip it upside down. Anytime you're undoing fractions, you want to multiply by the reciprocal instead of just leaving it that way. So you look at this, you say, whatever I do one side, I got to do the other. So 3/2. 4 times 3/2, remember that's the same thing as 4/1 times 3/2. These cancel each other out, so all I have left is x over here. And right here, I can multiply, I could do 4 times 3 and 1 times 2. and I can get 12 over 2. But the easier way, remember when we're doing fractions, we see, can we cancel anything out? 4 and 2 have what in common that we can reduce them by? 2. So 2 becomes 1, 4 becomes 2, 2 times 3 is 6, 1 over 1 is 1, so x equals 6 over 1, which is the same thing as x equals 6. Is this the same equation? Yes, it is. So you just need to show your work on those different ones on how they are the same equation, and then come up with the fact that they actually are. So you can look at guided practice 1 through 4 on page 195, check the back of the book to see if you have the right answer, and then you can start the assignment. Guided practice 1 through